To understand BPMN basics, let's look at the meaning of gateways. Gateways are drawn as diamonds and they represent places where control on the process flow is needed. There are different types of gateways. First of all, there's the exclusive OR gateway, where you will choose exactly one path. There is the inclusive OR gateway, where you may choose one or more paths. And there is the AND gateway, where you will choose all paths. Let's start with the XOR split. It's called a split because the gateway has two or more outgoing paths. It's an OR split because these outgoing paths are alternatives for each other, and it's an exclusive gateway because only one outgoing path is chosen. How is a choice made? Well, each path should be adorned with a condition, and this condition will be tested based on data known to the process. You can also make use of a default flow shown with a little dash on the outgoing path, and this means otherwise, so it means that if all other conditions evaluate to false, then you choose that path. So in terms of token semantics, suppose we have a red process instance. In this case, we test the condition is the payment okay? So the above arrow says no. The middle arrow says no, and we already exceeded the retry limit, and in this case both conditions evaluate to false, so we choose the default path, which is a yes path, and we will send a confirmation. For another process instance, we might choose another path. So for example, for this green process instance, the payment is not okay, and so we will go to the task send payment problem. The next kind of gateway is the inclusive OR split. So this is the same as an OR gateway, but now instead of an empty gateway or an X in the middle of the gateway, we put an O to signify that it's an inclusive OR. So it means now that one or more outgoing paths are chosen. So again, this requires a condition on each of the outgoing branches, but more than one condition may evaluate to true. And again, the conditions are tested based on data known to the process. So in this case, for example, for the red process instance, the token arrives into the gateway, the conditions are tested, and it appears that both condition 2 and 3 evaluate to true, so it means that both tasks C and D will be performed. The last type of gateway is a parallel split. The parallel split also has two or more outgoing paths, but in this case all parallel paths are followed, so it means that your token will be split in as many tokens as there are outgoing paths. So here you see the animation. So the red token arrives in the gateway, there are two outgoing paths, so it means that both paths will be followed. So you prepare the results and you will both post them on a website and you will email the results. Note that this parallel split has the same meaning as multiple outgoing paths of an activity. So you see on the right, prepare results has two outgoing paths. So it means that when the task prepare results is finished, this one token that is in prepare results will be split into outgoing tokens, one to post result on website and the other one to email results on Vote. So not using a gateway is the same as using a split gateway, at least for outgoing paths. Now that we know all about splits, let's look at how we can merge paths. And the first way to merge paths is with an XOR join. So in this case it's a join because you have multiple incoming paths into the gateway, and in this case you have one outgoing path. So the XOR in this case will behave as a multi-merge or as a pass-through. It means that it will be triggered once for each incoming token. It has the same meaning as merging without a gateway. So for each token that comes in one of the tasks B, C or D, this token will simply pass through the gateway and go to E. So in terms of an animation, you have 3 tokens in each one of the incoming tasks, and each token will simply be passed on to the next task E. So it means that E will be executed 3 times. The second way to merge paths is with an AND join. In this case, you will wait for a token on each of the incoming paths, and in this way the AND gateway forces synchronization. So let's look at the animation. You have 3 tokens on B, C, and D. So the AND gateway waits until B is finished, D is finished, and C is finished, and when all 3 tasks are finished, the 3 tokens are merged into a single token that is then passed on to the next task, E. And then finally, you can also merge paths using an inclusive OR join. So in this case, you will join some of the paths, not all. It behaves like an AND merge, but in this case, it only waits for the active paths. So this gateway here will know that there is B and D are active, but that task C, the path that comes via task C, is not active. So it will wait until B is finished and D is finished. So it has the 2 tokens, it merges them into one and continues to A. Here you see a little example of a process that combines split and join gateways. So when an order arrives, you check the stock. Then you have a split XOR gateway. So you will test whether there is sufficient stock. If there is not sufficient stock, you will reject the order. If there is sufficient stock, you will accept the order. After accept order, you have a split, and it's an AND split. Means that in parallel you will ship the goods and send the invoice. This is followed by an AND join, so it means you wait until the goods have been shipped and the invoice has been sent, and only when both tasks are finished you continue with handle payment. The parallel split means that ship goods and send invoice can be done in parallel. Doing tasks in parallel doesn't mean necessarily to do them at exactly the same time. It can be that you do first ship goods and then send invoice, or then first send invoice and then ship goods, or that by accident you do them exactly at the same time. That's not important. It means actually there is no order in which to do these 2 tasks. On the other hand, the AND join means that you have to wait until both tasks are finished before you can continue. So if we give a little summary of the different gateways, in terms of the split, the exclusive OR means that each token that comes in is routed to exactly one outgoing branch. The inclusive OR means that each incoming token is routed to one or more outgoing branches, and for the AND it means that each incoming token is routed to all outgoing branches. For the merge, it means that the exclusive OR means that each token that comes in is routed to the outgoing branch. For the inclusive OR, the merge means that you wait for an incoming token on each of the active branches and then route one token to the outgoing branch. And the parallel, the AND merge, means that you wait for an incoming token on all the branches and then route one token to the outgoing branch. Suppose in this case you would have excess tokens at incoming branches, they will wait for the next activation of the gateway. In terms of gateway, there are a number of good practices that you should keep in mind in terms of modeling style. First of all, you should avoid implicit gateways, because those gateways, they have a meaning, but they are not really clear. So in this case, you see task 6 is followed by task 7 and 8 in parallel, because there are 2 outgoing tasks of task 6. So this means actually it will behave as an AND split. On the other hand, task 7 comes after task 7 and task 8, and you might think this is also a matter of synchronization, but it is not. This combination follows the principles of an exclusive OR merge. So if you look at the tokens, you see that you have a single token in task 6. It will be split into 2 tokens that go to task 7 and 8. And then these 2 tokens will each simply go to task 9. So task 9 will be executed twice. So if you would use gateways, it will be this model, so with an AND split after task 6 and with an XOR join after 7 and 8 and before 9. The latter model with the explicit gateways is much clearer. It clearly shows what the behavior of the process will be, so avoid using implicit gateways, always use explicit gateways. It's also a kind of stranger behavior. In general, the advice is that gateway should come in split merge pairs of equal type. So an AND split should be followed by an AND merge, and an XOR split should be followed by an XOR merge. This would be a better practice than this hybrid combination of gateways. Another good practice is to avoid combining split and merge in a single gateway. If you look at the model on the left, you see that this gateway has 3 incoming arrows coming from task 1, 2 and 3. So it means that it will synchronize on these 3 tasks and it will wait until task 1, 2 and 3 are finished before it can fire. On the other hand, it has split semantics because it has 2 outgoing arrows. And so it means that after merging the tokens of task 1, 2 and 3 into a single token, it will split this token into 2 tokens, one for task 4 and one for task 5. A better way to represent this process model is as shown on the right. There you see first a gateway with merge semantics and join after task 1, 2 and 3, and then the single token is passed on to the next gateway, which has split semantics and splits the token into 1 token for task 4 and 1 token for task 5.